Hi everyone. In this bite-sized bit, we're going to discuss how to use for loops in our code for iteration. Let's go ahead and get started. In a previous video, I created an example in Visual Studio to compare while loops versus do while loops. I've used that code as a template for today's example, and instead of comparing while versus do while, in this case I'm going to compare while versus for loops. While and for loops, when using counter variables, are very similar in terms of their structure and almost identical in terms of their results. So it makes sense to compare these two structures for today's example. You can see I've made very small changes in terms of the name of the form, the name of the project, and replacing the do while loop with a for loop button. But other than that, this is very similar to the previous video. As far as my code is concerned, I still have my code for my while button, and I'm going to use that as a template for my for loop button. And in fact, I'm going to go ahead and copy and paste all of that code, including its comments, from our while method to our for method. And for the remainder of today, we're going to focus on this code in the for loop. I'm actually going to keep the while loop in this code, but since we're not running a while loop for this button, what I'm going to do is comment out the existing code. So I'm highlighting the code that we use for the while loop, and I'm clicking on the button at the top of my toolbar that says comment out the selected lines. This allows me to add the 2 forward slashes for comments automatically for code that already exists. If at some point I wanted to reverse that process, I can click on the button next to it to uncomment my code and start using it again. Nice little trick that allows us to keep code that we might want to revert to in the future or to reference from a note-taking perspective. Let's go ahead and create our first for loop. For loops start with the word for, and then an open parenthesis, and then we have to add 3 parameters. The first is the counter variable we're going to use inside our loop. I'm going to use int I, and I'm going to set it equal to a value of 1 to begin with. I type a semicolon, and then I type the second parameter we need to specify for our for loop, which is the criteria for repeating the loop. And in our case, we're going to repeat the loop anytime I is less than or equal to int number. The third parameter I'm going to type is what to do every time the loop completes. And in this case, I'm going to increment our I by 1. If you look back at our while code, you can see there are some clear similarities in terms of functionality. The question we're asking in order to go through the loop each time is whether or not the variable I is less than or equal to int number. We see that in both cases. Our counter variable I is defined with a starting value of 1. And every time our loop runs, I increases by 1. So the mechanics behind a for loop and a while loop are very similar, but in the for loop, a lot of those mechanics are built into its structure. There is one major difference in terms of for loops, and that is that our counter variable is being defined inside the loop, not outside the loop. And as a consequence, there's a different scope and lifetime for our counter variable. In this case, I has what we call a block level scope. It only exists while I'm inside these braces underneath my for statement. As soon as the loop finishes, I will be discarded. In our while loop, because I is defined outside the loop, it actually exists at the method level and exists the entire time the method is running. And it is only discarded when the method is complete. This sometimes has ramifications for certain types of code, but for most purposes in our class, either a for loop or a while loop will work exactly the same way. Inside our loop, our structure is going to look very similar. We're going to go ahead and increment our sum by adding I to it. So remember, if we type a 4, we're going to add 1 plus 2 plus 3 plus 4 to get a result. We're going to do the same thing inside our loop. What we're not going to do is type I++ inside the loop. We don't need to type it inside the loop because it's being handled by the for structure. When the loop completes, it will automatically increment I by 1. So we don't have that additional step. If you included I++ inside your for loop, I would increase not by 1, but by 2 every time the loop ran. And that's probably not what you're trying to accomplish. At this point, we're ready to run this code and see what it does. If I test my while loop with a for, we can see the result is 10. And if I test my for loop, we see the exact same result. And in fact, if we try other values for while and for, the results will match. And we will even see similar results when we type something like a 0, where we don't get any calculation for a while loop and we don't get any calculation for a for loop. I normally ask my students to go through the mechanics of breakpoint analysis on their own, but for today's video, we're going to go ahead and do breakpoint analysis together just to illustrate how the for loop structure operates. So I'm adding a breakpoint for my for statement and rerunning my program. And then I'm running my for loop. The first thing that happens when the for loop runs is that I is created. Before I reach this statement, I didn't exist. Now it exists and receives an initial value of 1. I ask the question, is I less than or equal to int number? And in fact, if I hover over the inequality, you can see that that is currently true. My code then starts to run the loop where it increments my int sum from 0 to 1. I reach the end of my loop. I increment my counter by 1. And then I re-ask the criteria question. Is I less than or equal to int number? In this case, that's still true. I keep running through the loop. Int sum keeps increasing. At some point, I will no longer be less than or equal to my int number. In this case, it still is. But one more time, when I becomes a 5, 5 is no longer less than or equal to 4. And so my loop quits, and I move on to my output, and I see my results on the screen. For loops are great for iteration where you want to use a counter variable, and in many cases will work exactly the same way as a while loop. While loops actually have more flexibility, especially if you don't want to use a counter variable for your loop structure. But when you're using counters, you may want to consider using a for loop. They are elegant, they are self-enclosed as far as defining the counter variable, the criteria, and the iteration. They look nice on the screen, and they accomplish the same goals as a while loop with a counter variable. That's it for this video. We'll see you next time.